Good morning, everyone. We have 8.3 Part 2 to go over today. We did do 8.3 Part 1 last class. If you're viewing this when I'm absent, I'm sorry I'm not here today, but I do have Theater Fest, but at least I'm here in spirit. So the first problem that we have on our paper, the 8.3 Simplifying Radicals Part 2, we have the 12th root of 2 cubed. So I'm actually going to go right ahead and convert that to a fractional exponent. So that would be 2. The index is 12, so that goes in the denominator. And 3 is in the numerator, because that's my exponent. From there, I'm going to simplify that fraction. So 3 over 12 can be simplified into 1/4. So it's 2 to the 1/4. And then just convert it back to a radical again. So 4 is my index this time, and I have an exponent of 2, which I don't really have to write out. Number 2, same concept. I'm rewriting this as 5. 6 is my exponent, 9 is my index. Simplify 6 over 9, so I have 5 to the 2/3. From there, I'm going to rewrite that again. So cubed root of 5 squared. And you can actually simplify this one further. I would take the cubed root of, you have to do 125, so the cubed root of 125. And then you know that the cubed root of 125 is, actually this is squared, so this is my fault. So just the cubed root of 25, my bad. Okay, so cubed root of 25. The next 4 are basically the same as number 2. I'm just going to simplify them further. It's just a review from previous classes. So in the first one, I'm taking the square root of 36 and then cubing it. Square root of 36 is 6. 6 cubed. And then 6 cubed is 216. So just a review from previous classes. We'll work through these. Cubed root of 125 squared. Cubed root of 125 is 5, and then I'm squaring it. 5 squared is 25. Number 3, square root of 4 to the 5th power. So we have 2 to the 5th power, which is just 32. And finally, the 5th root of 32. And I'm putting that to the 3rd power. So we have 2 cubed, which is 8. Okay, so the only real thing I want you to put in the summary, it's, like I said, just a review from before. You can write that the index is the denominator. The exponent is the exponent. By now, that should be pretty common nature. We are moving ahead slowly but surely. Just FYI, we are having a quiz next class. It will be on sections 8.1 and 8.2, which you already had a quiz on. You're going to get it back. And then we're going to add in a couple of problems from section 8.3. This one will be closed note, so don't even ask me. You're not getting notes for this one. It's closed note. All right, so number 1 in the multiplying radicals. So in the previous lesson, we were able to just multiply the radicands together because the index was the same in both radicals. In this case, they're not. So we need to figure out a way to get the index to be the same. So I'm going to go ahead and convert these to rational exponents right away. So I have 7 to the 1/2. Remember, if it's not written, it's a 2. Times 2 to the 1/3. I'm running out of ink. From there, I need to, and actually let's write the steps. So step 1, rewrite with fraction. colors. Now the second step is to make these denominators be the same. So I'm looking for my LCD. So in this case, 2 and 3, I'm looking for 6. That's the easiest one to do. If you multiply the denominator by 3, you have to multiply the top by 3. So 1 times 3 is 3. Then we have 2, the denominator 6. Have to multiply the denominator by 2, so I have to multiply the top by 2. So that's 2. So your step is write with common denominator. Going to convert back to a radical this time. So I have 6th root of 7 cubed times the 6th root of 2 squared. We have the same index now in both radicals, but before we multiply, let's evaluate those exponents. So I'm taking the 6th root of 7 cubed. Well, 7 cubed, if you put that in your calculator, you'll get 343. And 2 squared, you should know, is 4. So 4th step, evaluate exponent. Okay, final step, I'm going to multiply 343 times 4. And in your calculator, you'll get 1,372. So it's the 6th root of 1,372, and that last step is just using your product rule to multiply. I am going to move on to number 2. If at any time you need to pause the video to get things written down, that's no big deal. I'm not going to write all of these steps down so that the video doesn't take too long, but they are the same exact steps, each one over here. And I'll try and write them right next to here so they line up. So the first thing I'm going to do in number 2, I have the 6th root of 5 times the square root of 6. They do not have the same index. So I'm rewriting them both with fractions. So 5 to the 1/6 times 6 to the 1/2. Step 2, write with a common denominator. So 6 is still my common denominator. I didn't have to do anything to the first one because it was already there. And then we have 6 to the, whatever I multiply the bottom by, I have to multiply the top by, so it's 3/6. Step 3, convert back to a radical, so I have the 6th root of 5 times the 6th root of 6 cubed. Evaluate exponent. Well, the first one didn't have an exponent, so I can just rewrite it. Then 6 cubed is 216, so the 6th root of 216. Final step, use your product rule to multiply them together. So 5 times 216 is the 6th root of 1080. I would suggest checking both of these in your calculator. So get your calculator out if you haven't already done so. I'm going to cover this side up so we can check the one on the left. So in order to check this, I want you to put the top step in the calculator. So I'm taking the square root of 7 times the cubed root of 2. And if you still don't know how to get to the cubed root, I'm hitting math, then number 4. And that's the cubed root of 2. And I get my answer, 3.333, whatever. Now, the final one, so I want you to check this one with your final answer. And in order to put a 6th root in your calculator, and I'm not sure everyone knows how to do this one, you're typing 6, because that's my index, hit math, and arrow down until you see number 5. It says x root and it'll automatically work out for you. Your calculator might actually put the 6 in that spot, but mine's an older version, so it won't do that. Then type in 1,372, and you'll see that they're exactly the same answer. So if you see it on a quiz or a test, check your first original problem that they give you, so square root of 7 times the cubed root of 2, and then check it with your final answer. Same thing with the second one. So I have the 6th root of 5, so 6, math, number 5, and that's a 5, times the square root of 6. Check it with your final answer, so 6, math, 5, 1080, oops, and I get the same exact answer there as well. So we know that we check both of these and they work out. Your summary for this one, I'm going to have you write down just those steps. So your first step, you rewrite radicals with fractional or rational exponents. Write the fraction with a common denominator. Convert back to a radical after evaluating the exponent, so just put exponent. And then finally, you're multiplying. The only other bullet I really want you to put here is to make sure that you check it with your calculator. Now I know you're probably not done writing this all down. I do have to move to the back, so please pause it if you need more time. Okay, on the back, we are talking about the Pythagorean theorem. I know this is a geometry concept, and even in Algebra 2 we did this, but we do need to remember it. So the first thing I want you to do is write down just draw a triangle. It has to be a 90-degree triangle. We always call these two A and B, and these stand for the legs. C is always the hypotenuse. And this little square is a 90-degree angle. I would like you to write down a little example. So we have, and when you get your practice for today, it's actually going to be application problems of the Pythagorean theorem. So you'll have to draw a triangle for each one and the sides based on the words. You're not going to get a triangle for you. This is 6, this is 4, it's not drawn to scale, and that's C. So my formula is A squared plus B squared equals C squared. Plug in what you know. So A is 4, B is 6, and C I don't know. 4 squared 16, 6 squared is 36, equals C squared. Combine like terms, so we have 52 equals C squared. Now, I need to get C by itself, so I'm taking the square root of both sides. So C is equal to the square root of 52. Now, before you move on any further, I want to make sure that you are trying to simplify that as far as possible. So I'm rewriting 52 as, I'll write it as 4 times 3, or 4 times 13, I'm sorry. 4 can be written as 2 times 2. And from last class, you should remember that 2 times 2, that's my pair, and I do have an index of 2 over here, so I'm just looking for a pair of 2. So my final answer is 2, coming from over here, square root of 13, because that's what's left. Okay, we don't have too much left, but I do want to define the distance formula for you. And I don't know that anyone has ever actually done that before. You're probably going to get bored, but suffer through it anyway. So the reason why the distance formula works. So the first thing I want you to do in this little box down here is to put 2 points. So a point here and a point here. And I want to know the distance between these 2 points. So I'm going to call that D. Well, I can drop a perpendicular down to a point that is going to match up with this point. And I've created a triangle. Now this point, let's start with down here. I'm going to call this point x1, y1. I'm calling this point, we'll figure that one out in a minute. Let's call this one x2, y2. So those are my points that I'm trying to find the distance between. So x1, y1, x2, y2. These are my 2 points. So this point, since I dropped a perpendicular down, I went straight down on the y, so this is, or on the x and y, so I have x2, because this is at that same point, over x, and then y1, because I started at the bottom where y1 is. That's how I got this point. I went over x2, but I didn't go up any, so I stayed at y1. Now I want you to label your sides. So just like before, we had A and we had B. A is going to be this distance right here. I'm going to figure out by doing your we're finding the x value. So it's going to be x2 minus x1 for my A. That's the distance point to this point. The only thing that changed, the y's didn't change. The only thing that changed was the x's. So x2 minus x1. My B, that changed vertically. So I'm changing by y. So I'm changing from y2 to y1. Now I'm just going to plug in everything into my Pythagorean theorem to figure out what my D value is. So I'm going to write it a little bit backwards. So C squared equals A squared plus B squared. C in this problem is my D. So D squared equals, now A is x squared minus x1. So I'm plugging in my A value, x squared, x2 minus x1. But it has to be squared, and adding my B value, and my B value is right here. So plus y2 minus y1 squared. And just like in the Pythagorean theorem problem that we were just doing before, you need to take the square root of both sides. So I get D is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. And that's the formula that you're going to use for distance. So if this is on a quiz, which it is, you're going to need to memorize that distance formula, whether it be you defining it like we just did, or if you just memorize it blatantly. But you will need to know it for both the quiz and the test. So 2 problems actually using that formula are at the bottom. I'm going to plug in what I know. So D is equal to, now this is my x1, y1. This is x2, y2. So plug in what we know. We have 5 minus 2 squared, so 5 minus 2, plus 3 minus negative 1. Be careful with those negatives. And that's squared. So I have 5 minus 2 is 3, so 3 squared plus 3 minus negative, negative, negative make it positive, so I have 4 squared. Three squared is 9, 4 squared is 16. 9 plus 16 is 25. And the square root of 25 is just 5. So sometimes they're that simple. Sometimes, like in number 2, we're going to have to keep the radical in there. So d is equal to, again, this is x1, y1, 2, y2. So 0 minus, again, be careful with those negatives, plus, we have negative 4 minus 2. Zero, negative, negative make it positive, so I have 3 squared. Negative 4 minus 2 is negative 6, so make sure you keep those parentheses. 3 squared is 9, so I have 9. Negative 6 squared is negative 6 times negative 6, so that's 36. 9 plus 36 is 45, so I have the square root of 45. And then I'm going to simplify it like we did before. So 45, I'm going to split up into 9 times 5. 9 can be split up into 3 times 3. So I have 2 3's. So my final answer is 3, and this one is left over. So it's 3 square root of 5. So for your assignment, you are going to work on, now I think this class might have actually gotten a lot of this done already, but you're going to go back through and work on 105 to 113 odd. And in addition to that, there's a paper that you'll be getting, and it's all about the Pythagorean theorem. And it looks like this. It says Pythagorean theorem applications. There are 5 questions. You need to have this completely done, filled out, answers there, and will be collected for me to look at. And like I said, you are working on the rest of these problems if you didn't already finish them. These problems are extremely helpful. In addition to that, I would suggest looking at your notes from last class. You remember the quiz review practice that we did? Look at that, because all of those same questions are going to be on the next one. So just like we had the true and false section, the only difference is the true and false are now going to be questions like this, whereas the first 6 are exactly like the previous quiz that you took that was open note for the 3rd marking period. You are going to get them back at the beginning of next class, but you still have your review sheet, so you can study all of those things. Okay? I hope you have a great day. I will talk to you soon.